Hello, friends. Now we're going to talk about compound linear inequalities. So these are going to be inequalities where we have multiple inequality symbols written in the same problem or in the same line. So the first situation we're going to look at is when we have conjunction, compound linear inequalities written in conjunction. When we are dealing with inequalities written in conjunction, that means that x is in two different inequalities simultaneously. So we're dealing with an and or an intersection type of problem. Okay, we're dealing with where do these two intersect. So you may look at this and you say, okay, well, we've got the left and we have the right. And you'll notice that the x value is in the red and blue at the same time, which means both of these statements must be true simultaneously. I'm going to go about this a little bit of the long way, just to kind of help you really understand why it is the way it is. So we've got -2 is less than or equal to x, and because they are written in conjunction, we say and x is less than 5. So thinking about this on a number line, we've got -2 and 5. And now we're going to graph each of these. Now, x less than 5, that's easy for me to graph. Less than, I do a parenthesis, and I shade to the left. But when I look at reading -2 less than or equal to x, that's kind of difficult for me to think about. So I may just flip the whole thing as we talked about in the previous video. Remember, the alligator turns and faces the larger number. So we have x is greater than or equal to -2. So greater than or equal to, we're going to shade to the right. Because it's an equal to, we use a square bracket. So we look at where do the red and the blue occur simultaneously. And that is between -2 included and 5 not included. So my solution set here is that x is between -2 with a square bracket and 5 with a parenthesis. So really, you don't need to do all of this work. When you see something that looks like this and it's written in conjunction, least to greatest, left to right, your solution set is just going to be those two numbers, right? And then you're paying attention to the equal to or the not equal to determine bracket versus parenthesis. Let's look at one other conjunction example. So for this example, we have a more complicated linear inequality written in conjunction. Again, you see we've got two pieces. X is on the left and on the right inequality. So this is really why it's important for us to think about separating. So we have -1 is less than 2x minus 3. And then my other inequality I'm dealing with here is 2x minus 3 is less than or equal to 7. Since they are written in conjunction, we read that as and. X has to be in both the left and the right simultaneously. So it has to work in both of these solutions. So let's solve each and then think about where they overlap. So on the left, over here in the red, I'm going to add 3 to both sides. That gives me 2 is less than 2x. I'm going to divide by 2 on both sides. That gives me 1 is less than x, which doesn't make sense to read, so I'll flip the whole thing. X is greater than 1. And I'll solve my other inequality. I'll add 3 to both sides. That is 2x is less than or equal to 10. Dividing by 2 on each side, I have x is less than or equal to 5. All right, so number line, 1 on the left, 5 on the right, because 1 is less than 5. X is greater than 1, parenthesis, shade to the right for greater. And then x is less than or equal to -5. That is a bracket, and less than we shade to the left. So the solution set are the values in the middle where the blue and the red were occurring simultaneously. And that is x is between 1 and 5. We use a parenthesis on 1 and a square bracket on 5. So you don't have to necessarily separate both of them like that, but if you did have a situation where there were more than one variable, say you had an x over here, you may need to do this. So I'm going to look at a separate way to work this problem, which maybe has less work, but you just need to remember that there are situations where you may need to separate these two inequalities in order to properly solve them. So if I start over treating this like I have a wall here, I may choose to add 3 to each side, if you will, of this inequality. So that gives me 2 is less than, I'm left with 2x in the middle, is less than 10. Then I'll divide on each side or in each section. And that's 1 is less than, I left my equal to off there, 1 is less than x is less than or equal to 5, which we interpret as saying x is in between 1 and 5. 1 not included, 5 is included. So it's just kind of a shorter way of doing it. I do want to do one third example and show you a situation where you really do need to separate the two inequalities. In this example, we're going to look at again solving a compound inequality, but you'll notice we have x in each piece here. So it would really, if I started trying to move terms around and subtracting 2x, I would still get 2x is less than or equal to 6 is less than, I've got x plus 7. It becomes a little bit more difficult to figure out how to isolate my x value. So this is a situation where it's really helpful to be able to think about this as, being written in conjunction, like a Venn diagram. We have these two pieces overlapping. So my first piece I'll deal with is 4x is less than or equal to 2x plus 6. And the second piece I'll have here is 2x plus 6 is less than 3x plus 7. So separating was really crucial to making this easier for us to solve. So now I'll subtract my 2x. That gives me 2x is less than or equal to 6. I'll divide by 2 on both sides. X is less than or equal to 3. And the other problem, now when I think about trying to solve this and moving that 3x, I'll subtract 3x. That's going to give me a negative 1. So I'm going to choose to move the 2x over to the right side. I'll say minus 2x. And I have 6 is less than x plus 7. I'll subtract 7 from both sides. Minus 7. I have negative 1 is less than x. And of course, that's a little bit difficult for us to read, so that's the same as x is greater than negative 1. So if we look at graphing each of these, negative 1 on the left and 3 on the right, greater than negative 1 goes to the right, and then less than or equal to 3 goes to the left. And so the solution set is where the red and the blue are overlapping, and we would say negative 1 to 3. So x is an element of the set, or this interval from negative 1 to 3. And that's our final answer. So I hope you understand inequalities when they are written in conjunction. Let's look at disjunction now. Inequalities written in disjunction are going to include the word or. That means the solution is either in the left inequality or in the right inequality. So Remember, or is different than and. If I said you can have a pizza and $100, you would take both. If I said you could have a pizza or $100, you would need to make a choice. So let's look at solving each of these inequalities. So I have negative, I'm going to distribute that negative to both of those terms. Negative 5 minus 3x, it does not distribute to the 2, so we still have plus 2 is less than 0. Combining like terms, negative 5 plus 2, I've got negative 3 minus 3x is less than 0. Again, when I look at solving this, I have a choice to make. I can move either the 3 to the right or this negative 3x to the right. Since my x has a negative coefficient, I'm going to choose to move that term. So I have negative 3 is less than, when it moves to the other side, that becomes positive 3x. I'll divide on both sides by positive 3. Negative 1 is less than x, which we can flip, and that becomes x is greater than negative 1. So remember, we have the word or in between. And for my other inequality, that is x plus 3 less than or equal to negative 5. This one really has just one step to solve. I'll subtract 3 from both sides. I have x is less than or equal to negative 8. So let's look at this. Negative 8 is less than negative 1. So less than or equal to negative 8 means we shade to the left, and greater than negative 1, use a parenthesis, and we shade to the right. So because this is or, this is written in disjunction, we can be in the left blue solution set or interval, or the right solution set or interval. And we'll write our answer here saying x is in the set from negative infinity to negative 8, bracket, and the way we write the word or with interval notation is we do a union symbol. So we say union negative 1 to infinity. And that would be our answer for this problem. So it's just really important for you as a student to remember the difference between and intersection versus union and or. As always, get in touch with me if you need help. That's why I'm your teacher.